Hey Emery, this is Rachel. I wanted to create a video for you, and this is a common question. So I'm going to put this out on YouTube because a lot of people have a question on this one, and I'm just going to walk you through it. So thanks for bringing this up. This one, in this activity, this is lesson worksheet 32, and this activity we are calculating the perimeter and the area of the Koch Snowflake. So we're going to start with iteration 1. Now here's the key element. We are not measuring, we are using this triangle as a unit, as a measurement, okay? So we're not going to measure this like in centimeters or millimeters or anything like that. We are actually going to measure it in this specific triangle. All right, so here we have iteration 0. All right, we don't have the triangles right here, but we can see the triangles. Oops, we can see the triangles right here. So what I'm going to do is I'm just going to take a look at this triangle and calculate how many little triangles this measures. So I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So each side measures 9 triangles, right? So we have 9 times, now how many sides are there on this triangle? There's 1, 2, 3, right? So we're going to measure, or we're going to calculate that. Each side, which is 3 of them, measures 9, and that gives us a total of 27. All right, let's take a look at the area. Now, how do we calculate the area? Well, we know the area, the formula for a triangle, right? But that calculation is based off of a square unit, not a triangle unit. So how do we calculate the area for this first one? We are actually going to count these little triangles here. 1, 2, 3, 4, 5, 6, 7. I'm not going to do that, but you can do that and check it on your own. But there's actually going to be 81 little triangles in that one triangle here. All right, so now we're ready for iteration 1. Now notice, that's exactly what's written here, okay? It looks the same, so we basically have one triangle there, one triangle there, all right? So we have the perimeter of this triangle, right? So we're going to incorporate that. So we have 27, and we're going to add to it some more because now we have these little offshoots of triangles, don't we? All right, so now let's take a look at this. What is the perimeter of each one of these little offshoots? Well, that would be 1, 2, 3, okay? And there are 3 of them. Now you're like, wait a minute, what about this side? Well, we lost this side here. This is actually kind of like a door. So consider this disappearing and going up there, right? So if we have it sliding open, this becomes that, okay? So we really only have 1, 2, 3, 1, 2, 3, there it is, 3, and there's 3 points. So we're going to say 27 plus 3 times 3, which is going to give us a total of 36 units. All right, now let's take a look. What would the area be? Well, the same thing. We already have the area of the first triangle, right? So that would be 81. And we're going to add to that the area of each one of these little offshoots. Well, we can figure out what the area is of that by counting the little triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 of them. So, but each triangle, each offshoot is 9 units, but there are 3 of them. So we're going to do 3 times 9, okay? And that's going to give us a total of 108. All right, now let's take a look at the instructions for iteration 2. Now this iteration and this iteration are the same, so something's not right here. What needs to happen? Well, what we need to do is we actually need to draw iteration 2 of the Koch Snowflake fractal, okay? So this is the same, so we need to draw the next iteration, okay? Now in the book, you can see kind of what that looks like. So here's iteration 1. Here's iteration 0, iteration 1. Now what this has is it adds these little points offshooting each one of these larger points, right? So that's what basically we're going to do. We're going to draw these little offshoots like this. see that one and that one. Okay, now notice off of each point, how many am I drawing? I'm drawing 1, right? I mean 2 off of each of these larger points. So this point here has 2 offshoots, right? And each of these offshoots is 1 unit, right? So for this point, I have 2 units. I've added 2 units. For this point, I've added 2 units. So that's going to go a long way in determining my area, right? And my perimeter. So here we go. Let's do the area first. 108. And we know that we had added 2 of these per each triangle. So there's 2 times, and how many points are there? There are 1, 2, 3, 4, 5, 6. So we've added 2 times, that's a 2, that looks like a 7. 2 times 6, okay? And that's going to give me a total of 120. All right, now let's come back to iteration 2 for the perimeter. Now in this particular case, we're going to, first of all, just like with all of the other ones, we're going to drop down this number and pull it down here. All right, now the instructions in the manual give us a hint. Okay, on page 2 of this, okay, it'll say each new side is 4/3 as long as the original side. Key, because that's going to tell us how to calculate our sides from here on out. And actually, this will actually work on this one too. I'll show you in just a second. So 36 times 4/3, okay, equals. So we can calculate that out by typing in 36 times 4 equals divided by 3 equals, and that will give me the perimeter of 48. Now, will that have worked with this one? Did I need to do the 3 times 3? Let's try it. 27 times 4 divided by 3 equals 36. So yeah, that ratio would have worked for that as well. So you're going to continue that. You're going to take our previous perimeter, 48, times 4/3 and calculate that out. 48 times 4 divided by 3 is 64. And we're going to continue on through the rest. Now they have calculated out the area for you, so you don't need to do that because now we're getting into partial units. But anyway, I hope that helps. Let me know if you have any other questions. Take care. Bye-bye.